I work in company MikroTik, and today I will tell you about 60 GHz range improvements and multipoint capabilities. Before we start talking about 60 GHz equipment, we should remember some important characteristics about 2.4 and 5 GHz equipment. The minuses of 2.4 GHz equipment is that it is overcrowded and it has relatively it doesn't have much channels. In most countries it is only 13 channels, and you can create only 3 non-overlapping channels. And the advantages for 2.4 GHz frequency range is that you can achieve higher distances, and also it better penetrates through objects like walls or other obstacles. When we talk about 5 GHz equipment, I suppose the first minus is DFS radars, which is used to do not allow the 5 GHz equipment to interfere with the meteorological radars, and the minuses is also that for 5 GHz the channels are rapidly increasing. Like now it is possible to set 160 megahertz wide channels. Of course you can achieve greater throughput, but you will suffer due to that you can choose less channels. But of course the advantages of 5 GHz is that you can achieve higher throughput, and there are much more available channels than it is for 2.4 GHz. When we talk about 60 GHz frequency range, the disadvantages are oxygen absorption. You can achieve relatively short distances, and it has less channels than it goes for 2.4 and 5 GHz frequency range. But the main advantages is that you can achieve much more greater speeds, and the frequency spectrum is relatively free, because there isn't much of 60 GHz equipment used nowadays. Here we can see that historically the 60 GHz frequency range wasn't used in radio communication because it has relatively high dBm over kilometer absorption by oxygen. It means that it has the main disadvantage is it gets pretty well absorbed by oxygen, and it is also a plus because it doesn't create as much interference as it goes for 2.4 and 5 GHz radios. The 80.11 AD spectrum in most countries is unlicensed. You don't need specifically to buy a license as it goes for FDD radios, but for more precise information you should contact your local telecommunication regulator. The attenuation helps avoiding interference from other radios, and it is possible to achieve higher gain by creating very narrow radio patterns, and physically smaller antennas that can provide higher gain. Here we can see a wireless wire kit. The device you can create a point-to-point link for up to 200 meters, and the device is pre-configured plug-and-play device. It comes with a 4-core CPU running at 760 MHz, and it's equipped with 256 megabytes of RAM. The max power consumption is only 5 watts, and it works accordingly to the 80.11 AF/AT PoE standard. Currently, the range is up to 200 meters and more, and that is while still achieving 1 gigabit per second of full duplex link. It means 1 gigabit download, 1 gigabit upload. And also, it has very great feature beamforming, which means that if by any case the antenna is moved, the beamforming patterns will switch and find another way to recreate a radio connection. And also there's point-to-multipoint support. You can add up to 8 devices for one access point. The channel width of wireless wire is 2.60 GHz. It's almost it's like combining the whole 2.4 and 5 GHz spectrum together. The total ERP is under 40 dBm, and it's certified under ETSI. The antenna consists of 32 antenna elements, and for better performance, it sweeps between 64 antenna patterns. The wireless coverage is close to 180 degrees, and price for a kit is $198. It is also possible to buy separately each device. You can, if perhaps you want to buy only a client device, you can buy WAP 60G. That basically is the same hardware as the wireless wire, and the only difference is it comes with license level 3, and you can create a point-to-point link between two devices, or you can use it for point-to-multipoint setup for up to 8 devices. The total ERP is under 40 dBm. The device has the same certification as wireless wire, and the price for device with level 3 license is $99, and for device with level 4 license it's $129. Then we have a product S60 Square Lite 60. This device, if you pair them, is used for distances up to 200 meters. It has a slim design. It's certified under ETSI, and it comes with license level 3. It's equipped with a fast Ethernet port, which supports 100 megabits per second. But if you are using it as a client device, you don't need to additionally use any traffic shaping mechanisms, because the speed will be limited to 100 megabytes per second. And the price is $69 for one device. Here you can see LHG60 kit for distances up to 1,500 meters. The antenna gain is 42 dBi, and the total ERP is under 55 dBm. The device is certified under ETSI 302.217, and it is fixed point-to-point compliant. The device comes with license 3 level, so it basically means you can create a point-to-point link or point-to-point bridge. And the price for a kit is $298 for a kit. The wireless modes for 60 GHz equipment are similar as it is for 2.4 and 5 GHz. There is AP bridge for point-to-multipoint setups, bridge for point-to-point setups, station bridge for client device, and sniff for checking if you see the opposite side. It's basically for scanning the frequency spectrum. The configuration is very easy. You go under in the command line interface under interface V60G, and you just need to specify the SSID, password, and the mode: bridge, AP bridge, or station bridge. Here you can see wireless comparison with other MikroTik devices. The highest wireless throughput compared to any MikroTik wireless device at the moment. If we test a 2.4 GHz dual chain device, it can achieve transmit 256 megabytes per second and receive 255 megabytes per second. And combined, you can't get any better because it is limited to approximately 252 megabytes per second. And the test was done with R11 to HPND card, which was mounted on RB800. And we also compared the speed to 5 GHz dual chain card. We were able separately to get transmit speed 500 megabytes per second and receive 561 megabytes per second. And the total throughput is approximately 570 megabytes per second. And it was achieved with R11 5 HP ACD card, which was installed in RB800. And when we tested the 60 GHz device, the speed was limited due to the Ethernet. We were able to get transmit 1 gigabyte per second and receive 1 gigabyte per second. And combined, we were able to get 2 gigabytes per second, for which is like full gigabit duplex Ethernet link. You can use it as a backup or for optical links or as you wish. Here we can see the performance for 1.5 kilometer link. The performance is very smooth, and in this test you can't see any bumps or disconnections because the devices work very stable. Here we can see performance comparison to wired network. We can see that if we use 64 to 192 byte packet sizes, we can't reach the same speed as it is for the wired cables, but packet sizes over that, starting from 2.69 byte packets, it is the same as it is for a wired network. You can basically create a wireless wire. That is why the naming is created like that. And the test was done with UDP traffic, with Xena network specialized test equipment, and done accordingly to RFC 2544 Ethernet test. Here we can see a graph where we can see that the performance matches at 192 byte packet sizes, and after that we get identical performance as it is for a wired network. As it goes for point-to-multipoint support, it was experimental added in the RotorOS version 6.41 and newer. It requires for the AP device at least level 4 license, and connected clients are treated as individual interfaces. It is very easy to configure it and to manage them. The point-to-multipoint setup supports up to 8 simultaneously connected clients. And here we can see a point-to-multipoint performance test up to 400 megabytes per second simultaneously to each client in point-to-multipoint setup. The all devices WAP60G, SXT260 and LHG60 are mutually compatible. You can create the network as you wish. The WAP AP60G makes excellent access point for point-to-multipoint setup, and the usage together with LHG60 client devices, it can achieve relatively far distances. It is very easy to deploy and easy to configure the devices, and also you can monitor the devices using SNMP. Currently, this is the fastest point-to-multipoint solution at this price range. Here we can see some measurements where WAP60G was paired with LHG60. We were able to reach full gigabit over distance of over 600 meters. When it went farther, the speed dropped a little bit, but we were able to reach 100 megabytes per second duplex speed over 900 meter of distance. The test was done before the latest software changes for increasing the distance. WAP60G new features. There are calibrated antenna sectors, increasing the distance over 200 meters. For WAP60G, a RotorOS update is required, and increasing the wireless wire dish's maximum distance. Currently, it can go up to 4 kilometers and more. We have added SSL for monitoring signal strength to make the alignment more easily. Also, there is added a very precise distance measurement tool, and we have updated beamforming pattern information for easier LHG60G alignment. There have been done more improvements in beamforming efficiency, the throughput improvements when the link is fully utilized, and there was done major point-to-multipoint throughput improvements to achieve greater speed with up to 8 clients. Recently, we added 4th and 5 channel, which is 64,080 MHz or 60.48 GHz and 66 GHz frequency, which is only available through command line interface, and these frequencies support distances up to 4 kilometers. Due to that these frequencies are not absorbed by the oxygen as well as it is for the 60 GHz frequency itself. There also are added new align feature in the RotorOS. You can see that now the align feature looks like this, and the changes are that it works faster and you can get the data faster and more precisely, and it helps you to align the device more precisely if you are doing the link alignment for larger distances. Also, there are some alignment tips. If you are installing the link in rainy conditions, you can achieve better antenna gain if you use 66 GHz frequency, because if you use 66 GHz frequency instead of 60, you can get additionally 50 dBm 4 kilometer to get better RSSL signal levels. Here we can see the new align feature when it is implemented in RouterOS. Also, there's added for LHG60 LEDs to make the alignment more easy. It basically means if you move, it shows you in which direction the device should be moved, up, down, left, right. And it also shows if there is a wireless link created. So you actually don't need a second person or a computer when you are doing a PC when you are doing alignment. Tips and tricks for testing. I will give you a few suggestions for testing. It is preferred to not run tests and tools on the device itself. You shouldn't use generate the traffic with a bandwidth test on the testing device, because the CPU will eat up the resources and you won't be able to see the real throughput. You also, for testing, you can use other tools like I would recommend use traffic generator, because you can use multiple streams and achieve greater speeds than it is for bandwidth test. Here are some recommended testing software. You can use RouterOS with bandwidth test, or you can use iPerf or iPerf 3, which works on PC, Mac and Linux. And also it is possible to use online tools like speedtest.net. And of course there are various tools in the internet. You can use one which is more which is more useful for you, for your needs. Thank you for your questions. Maybe do you have some questions? Of course, if there is heavy rain or the snow interrupts the direct line of sight, you could see link disruptions. But in cases if you are using the device as a point-to-multipoint, as a point-to-point setup, you can create a backup with a 5 GHz link. Because also if you would use like FDD equipment, which is much more expensive, if the weather gets pretty harsh and you don't get direct line of sight, the data rates definitely will drop and the throughput will decrease either way. And that is why I would recommend, if the link is important, to create a backup which is looking at the same direction.
So we would expect a complete loss of signal between the link, or just
It depends from the intensity. If it is heavy rain and you don't have a direct line of sight, if you can't see the other side of the link, most likely it will get disconnected, because the antennas, the takes power is limited, and most of the gain is achieved with the antenna. Do you have some more questions? Okay. Then that's it from me, and I want to say something. Fale menderit.